Now that we're familiar with the various mathematical time values of the notes with relation to one another, and how these notes are depicted on the musical staff, we can discuss the meaning and purpose of the bottom number of our time signature. As we recall, the top number of any time signature indicates the number of beats each measure will contain and whether those beats will be grouped into sets of 2s, 3s, or 4s. The bottom number of the time signature indicates the amount of time that each beat will receive by way of a note value so that we can combine or divide the beat in a way that results in both mathematical and visual equality in each measure. The bottom numbers indicate note values in the following manner. The number 2 indicates the value of a half note. Thus, a time signature of 2-2, 3-2, or 4-2 indicates that there are 2, 3, or 4 beats per measure and that each beat has a value of one half note. A 4 indicates the value of a quarter note, and a time signature of 2-4, 3-4, or 4-4 indicates 2, 3, or 4 beats per measure, with each beat having a value of one quarter note. An 8 indicates the value of an eighth note, and a time signature of 2-8, 3-8, or 4-8 indicates 2, 3, or 4 beats per measure, with each beat having the value of one eighth note. And a 16 indicates the value of a 16th note. A time signature of 2-16, 3-16, or 4-16 indicates 2, 3, or 4 beats per measure, with each beat having the value of 1/16th note. Keep in mind that the note values, half, quarter, eighth, and 16th notes, have nothing to do with the actual speed of the beat, but merely serve as numerical values by which the composer can combine or divide the beat so that the total note values per measure will equal the sum of the beat values and that the visual patterns created will coincide with the rhythmic pattern desired. Mathematically and visually, this results in a wide range of beat combinations and divisions. For example, using a time signature of 2-2, where the beat is represented by a half note, a division of 2 quarters is equal to 1/2. Observe how the visual pattern allows us to anticipate the drum pattern. A division of 1/4 plus 2/8 is equal to 1/2. A division of 1/4 plus 1/8 plus 2/16 is equal to 1/2. A division of 1/4 plus 1/8 plus 1/16 plus 2/32 is equal to 1/2. Therefore, any combination of note values that add up to 2 half notes can be correctly placed within a single measure having a 2-2 time signature. Another example shows how this pattern of division can be reproduced in the 2-4 time signature, where the beat is represented by a quarter note. The division of 2/8 is equal to 1/4. The division of 1/8 plus 2/16 is equal to 1/4. The division of 1/8 plus 1/16 plus 2/32 is equal to 1/4. The division of 1/8 plus 1/16 plus 1/32 plus 2/64 is equal to 1/4. Again, any combination of note values that add up to 2 quarter notes can be correctly placed within a single measure having a 2-4 time signature. By the way, the same relationships can be applied to the placement of rests as well. We run into a special situation, however, when the top number of a time signature indicates 3 beats to a measure, and that is that the number 3 cannot be evenly divided by 2. For example, how can we notate a tone that is held for 3 beats? A whole note is designed to hold a count for 4 beats, while a half note is meant to hold a count for only 2 beats. We introduce now then the symbol of a dotted note. A dotted note can be thought of as shorthand for a group of 3, or perhaps more accurately, 2 plus 1. Mathematically speaking, the value of a dotted note is equal to the note's original value plus 1/2 of its original value. For example, a dotted whole note has a value of its original value, 1 whole note, plus 1/2 its original value, 1/2 note. Since in a 3/2 time signature there are 3 beats to a measure, and each beat has the value of a half note, each measure can be considered to be made up of a group of 3 half notes. Because the whole note is equal to 2 half notes, a dotted whole note can be regarded as a group of 3 half notes, or a group of 2 half notes plus 1 additional half note. The same is true for a dotted half note. It has a value of 1 half note, which is equal to 2 quarter notes plus 1/2 its original value, 1 quarter note, for a total of a group of 3 quarter notes, or a group of 2 quarter notes plus 1 additional quarter note. A dotted quarter note has a value of 1 quarter note, which is equal to a group of 2 eighth notes, plus 1 additional eighth note, for the total of a group of 3 eighth notes. A dotted eighth note has a value of 1/8 note, equal to a group of 2 16th notes, plus 1 additional 16th note, for the total of a group of 3 16th notes. So, when our time signature indicates 3 beats per measure, we use a dotted note rather than a whole note when we want to show a combination of beats over the entire measure. For example, when our time signature indicates 3/2, a dotted whole note is used to combine the 3 beats over the entire measure. When the time signature indicates 3/4, a dotted half note is used to combine the beats. In 3/8 time, a dotted quarter note combines the beats. And in 3/16 time, a dotted eighth note combines the beats. We can also use dotted notes in duple time signatures, like 2/4 and 4/4, to divide the beat, or subdivisions of the beat, into groups of 3 plus 1. Because a dotted note receives its original value plus 1/2 its original value, or it presents itself as a group of 3 notes of half the original value, it can be combined with an additional single note of half its original value to create an auditory grouping in duple time of 3 plus 1. For example, in the illustration, our top staff gives us a time signature of 2/4, which tells us that there are 2 beats in each measure, and that each of those beats has a value of a quarter note. We know then that any division of the beat, when individual note values are added together, must equal the value of a quarter note. Take a look at the first 3 plus 1 pattern in the top staff of our illustration. It consists of a dotted quarter note followed by a single eighth note. The dotted quarter represents a combined group of 3 eighth notes. The 2 quarter note beats have the total value of 4 eighth notes. So the dotted quarter note representing a group of 3 eighth notes requires only 1 additional eighth note to equal the value of 2 full beats. This 3 plus 1 pattern has a unique sound. In the case of the dotted quarter followed by an eighth, the dotted quarter is sounded and then held through the first 3 eighth notes, followed by a sounding of an additional eighth note. As played on the piano, this sounds like. Looking at the second 3 plus 1 pattern in the top staff of the illustration, we find a dotted eighth note followed by a 16th note. This combination is equal in time to 1 quarter note, or 1 beat. The unique sound of the 3 plus 1 pattern remains, but would be played twice as fast as the previous dotted quarter eighth. Now, moving to another subject, we'll introduce the concept of simple versus compound meters. The completed time signature gives us what is known as an organized meter. For example, we would say that a time signature of 2/4 gives us a meter of 2 beats per measure where each beat is worth 1 quarter note. When the top number of a time signature is a 2, 3, or 4, we describe it as a simple meter. Furthermore, when the top number is a 2 or 4, we descriptively call it a simple duple meter. Or when the top number is a 3, we call it a simple triple meter. Quite often, however, we encounter time signatures such as 6/8, 9/8, and 12/8, or 6/4, 9/4, and 12/4, where the top numbers are multiples of 3. From our previous discussions, you might assume that a time signature of 6/8 tells us that there are 6 beats per measure and that each beat is worth 1/8 note. But things get a little out of the ordinary here, and reading time signatures having top numbers that are multiples of 3 becomes a little more involved. Let's take a closer look at these time signatures to see what's really going on. Start with the 6/8 time signature. Listen to the pattern shown in the illustration. The first thing we notice is that the underlying beat pattern is not 6 beats per measure, but 2 beats per measure. The second thing we notice is that each beat has been divided into sets of 3 rather than sets of 2 or 4. This means that each beat has a value of a dotted quarter note. Displaying the correct time signature for the beat, in this case, becomes a problem. It would be confusing and very difficult to read if we were to write 2/4 dot, even though this is technically accurate. Over many years, musicians have come to an agreement that the best way to display this time signature is to simply state that there are 6/8 notes per measure. After that, it falls to the musician to divide the top number by 3 in order to find the actual number of beats per measure. Thus, 6 divided by 3 gives us 2 beats per measure. Since each beat has been divided into groups of 3/8 notes, we can add the eighth notes together to determine that each beat has a value of a dotted quarter note. At that point, we understand that 6/8 time is actually a duple meter. Because we've divided the beat into groups of 3, and because we actually hear these groups of 3 playing on top of the underlying 2 beat groups, we call this type of meter a compound meter. Further, because the actual beat pattern is 2 per measure, we call it a compound duple meter. The time signature in any compound meter represents both a simplification and fusion of all that is really going on. A 9/4 time signature tells us that there are 9 quarter notes per measure. Since the top number of the time signature is divisible by 3, we know that we are dealing with a compound meter. When we divide our top number by 3, we determine that there are 3 beats per measure. Thus, we have a compound triple meter. Because each beat has been divided into a group of 3 quarter notes, we know that each beat receives a value of a dotted half note. Performing the illustration, we hear the underlying 3 beats per measure, with each beat being divided into groups of 3. A 12/16 time signature indicates that there are 12 16th notes per measure. When we divide 12 by 3, we determine that there are 4 beats per measure. Since each beat has been divided into a group of 3 16th notes, we know that each beat has a value of a dotted 8th note. Again, because the 12 is divisible by 3, we know that we are dealing with a compound meter. Since there are 4 beats to a measure, we call this a compound duple meter. Performing the illustration, we hear the underlying 4 beats per measure, with each beat being divided into groups of 3. This concludes part 2 of our lesson on the communication of duration, rhythm, and speed of musical tones. Our next lesson will continue to introduce more of those ideas and practices.